It's my immense honor and pleasure to invite to Living Histories Ralf Bundschuh, who I have known as a professor. So I'm particularly excited to hear Ralph's Living Histories.
Well, hello, everybody, and thank you to the organizers for allowing me to share some of my career trajectory and a little bit of career advice. Uh, to get started, I was born in the southwestern corner of Germany, in Freiburg and Breisgau, into an academic family. My mother was a mathematics and physics high school teacher, and my father would soon become a professor of mathematics at the University of Cologne. So this is where I grew up since I was 5. I developed a fairly early interest in anything electrical, which then further developed in me tinkering a lot with electronic circuits. And so it was just natural that when computers came around, I was all over those computers, started programming, as well as designing and building my own. In high school in Germany, you in 11th grade choose 2 topics where you have more classes per week than in any of the others. And so, maybe not surprisingly, given where I came from, one of those was mathematics, where I had an absolutely amazing math teacher. Thank you, for Schmidt. And then the other one was physics, where I had a teacher who really had a large influence on me because he allowed me and a group of students to basically spend all our study halls in the physics demo room of the school and put together the experiments for him. So this was really a great time where I could explore physics through putting experiments together. He unfortunately also did have quite some interesting stereotypes, and so he did let me know that because I'm tinkering so much with electronics, I would never be able to be successful in physics, which clearly was completely wrong, just as much as the fact that he told the only female student in our class that as a girl she could never be successful in physics. And so this takes me to the very first lesson of this presentation, namely that you really should ignore any naysayers and you should avoid stereotypes. If you're thinking about going into a teaching career, ideally never think along those lines, but even if you have to think about them, at least don't express it to your trainees. I stayed in Cologne for my undergraduate and enrolled at the University of Cologne, again, not that surprisingly, as a mathematics and physics double major. The first time to then really make a career choice was when it was time to choose a thesis direction. Back then, the German system had a 5-year undergraduate degree, of which the last year was a research year that culminated in writing a thesis. So I had to interview a few professors. It came down to experimental astrophysics or condensed matter theory. In experimental astrophysics, I learned that I would work on a radio telescope and might have to spend a winter in Antarctica. And so that was for me enough of a reason to say that I should really become a theorist. And so I worked in sort of hard condensed matter theory, looking at conductance fluctuations with some mathematical physics methods. After my undergraduate, it was time to choose a PhD thesis direction. In Germany, one applies directly to a faculty rather than first applying to a graduate program and then looking for an advisor within this program. So I looked at various labs, applied, visited a few, and then picked a group that was at the Forschungszentrum Jülich, fairly close to Cologne, that did theoretical soft matter and polymer physics. So you notice still not biophysics, but getting a little closer. I already knew when I started there that my advisor would become a Max Planck director at a newly founded Max Planck Institute in Berlin. So that is where I actually spent most of my time as PhD student. Unfortunately, my advisor and I were a really bad mismatch personality-wise. And so it turned out that my PhD time was quite challenging, and actually both on the professional side as well as on the personal side. Nevertheless, I did come out eventually on the other side with a PhD. And so the lesson from that is that you really sometimes have to be resilient, even if things don't go quite the way you were hoping for. After my PhD, I went back to Cologne for a one-year postdoc, mostly to wrap up some things that I started as an undergraduate, but then also to really look at postdoc opportunities that are a little bit longer. Germany being not such a large country, you are basically expected, if you want to become an academic, to go abroad. So I applied everywhere in Europe, in Asia, in the US. Wasn't very successful with that. I then started applying for a postdoctoral fellowship from the German government to go abroad. I sent an application to a faculty at MIT asking if they would take me with my fellowship. And this faculty member said, well, sorry, I don't even have a desk for you, even if you bring your own money. But that he had this colleague and friend that he forwarded my application to. And through this happenstance is how I ended up at the University of California in San Diego with Terry Waugh. And that is where I was introduced to biophysics. So there I had a fantastic time. I learned about RNA. I learned about sequence alignment. And I really just had an opportunity to develop as a scientist. This was also the time that I met my wife of nowadays more than 25 years. So the moral out of all of this is that what you did not plan for can be even better than what you originally planned. So, I mean, in one sense, this was not a position that I expected. And the other way, through this personal development, the plan of going back to Germany after a short time changed completely, and I stayed in the US. Finding a faculty position was then fairly uneventful, 50-some applications, 8 interviews, and 2 offers later. I ended up being a newly minted assistant professor at The Ohio State University, which is where I've been ever since. Of course, being in a faculty position for more than 2 decades, your research still evolves. I came in as a statistical physicist working on biological systems, but really looking at physics questions, phase transitions, critical exponents, those kind of things. That actually turned out to be difficult to find funding for. My first dozen proposals were all rejected. And the key to actually being funded was to move significantly toward real biological questions and talking to and working with biologists. That is why I would like to give anybody who wants to do biophysics the advice to really become fully conversant in the language and thinking of biologists, because in the end, we want to answer real biological questions with our physics methods. Before I'm coming to a close here, I want to talk about 2 more chance encounters, because I think this is really sort of the theme of this series that had a large influence on my career. So one was standing in line for the coffee behind my colleague Jonathan Gott from Case Western Reserve University at a local RNA meeting very early on in my first year as a faculty, and learning from her about the fascinating area of RNA editing. And that led to several papers and 6 years of NSF funding for developing methods to predict RNA editing, just because I was standing behind her in this coffee line, from which the lesson follows that the talks at conferences mostly exist so that we can tell the taxpayers and our family why we need to go to the conference, but the real science happens at the coffee breaks. So you can skip a talk, but never skip a coffee break at a conference. The second chance encounter was when I was starting to get into the field of genomics. High-throughput sequencing had just become a thing. I had dabbled in it a little bit, but it really took off when an astrophysics colleague of mine who had a membership at the faculty gym at OSU, ended up on the treadmill next to who was the new director of the high throughput sequencing facility. They started talking as they were on the treadmill. And at the end, my colleague told this new sequencing director, well, you should really talk to Ralf Bundschuh. And from that, many dozens of papers and 10 years of collaboration in high throughput sequencing evolved. Of course, one moral from this is that you really cannot direct necessarily what your trajectory is, but you can look out a little bit for where opportunities are. So by being aware of technological breakthroughs, such as in this case, the high throughput sequencing, where I was one of the early experts in how to analyze this kind of data, can have a large impact on your career. So I already threw all these lessons into the talk, so I will actually just close with thanks. I would like to thank all my family members, especially my parents and then later my wife, who really supported all these various endeavors that I got myself into. My teachers and mentors from whom I learned a tremendous amount. My wonderful colleagues and collaborators, it should be clear by now that I really thrive from bouncing ideas from people, from talking to people that are experts in different fields. And then lastly, to my trainees, who made it a great experience to be a faculty member, and who then were able to go on and take the things that they learned in my lab and take them in totally different directions, both in industry and in academia. And as a last lesson, I want to close here and say that it's really about the people you interact with more so than the actual science. So thank you for this opportunity to share this.
Wow. Thank you so much for a wonderfully engaging and inspiring talk, Ralph. Um, there are a few questions. Let me ask one from the audience first. Um, how to deal with an unhappy relationship with PhD supervisor, especially in a system where letters of recommendation are so key? Wow, that's a heavy one.
That's a heavy one. And I should say, I mean, of course, I never read my letters of recommendation, but I did get jobs. So the letters of recommendations, even though it was difficult, must have been good and fair. Um, so I think a key thing was for me to really build a community around me with fellow graduate students, uh, having really a community that supports you uh, was really key for me in this case.
Thank you. Conversely, how does that experience inform your dynamic with your PhD students?
Well, so I mean, my philosophy is certainly that it's not there's not necessarily a good advisor or bad advisor, but there's good matches between advisor and student, and there are bad matches between advisor and student. So I think that one thing is that in the U.S. system, by being able to rotate in a lab, one gets a much better insight into how the advisor-advisee relationship is working out, than maybe in a system where one has to make this decision on very little data. But of course, I also do try to be open to adapt to different mentoring styles for depending on what the student needs. So I mean, it's I think both it's the ability to recognize what are good matches and trying to be flexible.
Thank you, Ralph. In the interest of time, if you could answer in a few seconds, is there a way to plan to have useful serendipitous interactions?
Well, so one thing is to go out there and be places. So I think that's, I mean, I have had many serendipitous interactions that led to absolutely nothing. So it is a numbers game. that you have to be open and excited about learning about new things, and just be in places where you can run into people, and then hopefully some of those are the ones that I told you about. But you have to have enough of them for some of them to be productive.
Great. Thank you. On that very inspiring note, I'm thanking you again on behalf of the audience. And